We are going through exercise 13G. In this video, I'll be answering question 1A. Let's give it a read. So it says, sketch the graph of each of the following and state the domain and the range for each. So here we have y equals log base 10 2x. Now, we know what our general log graph is going to look like, and we know that the only way that this really deviates from being just your stock standard one is this 2 right here. What this 2 is telling me is that we're going to have a dilation of a factor of half from my y-axis. But before we delve into that, let's begin by simply writing down what my domain is. So what is my domain? My domain. Well, I know when it comes to log graphs that my argument here, so what I'm actually logging itself, what's inside my brackets, it has to be greater than 0. So right here, 2x is going to have to be greater than 0. And think about that for a second. If I was logging 0, it wouldn't work. You can't log 0 and you can't log a negative number. So that means whatever is inside here, whatever it is, you just say it has to be greater than 0. That's how you find your domain. Now, obviously, I can divide both sides by 2. So that means what I'm going to end up with is x is greater than 0. Now, there's obviously other ways you could represent this. You could say that it is 0 to infinity and just make sure that you have a round bracket around your 0. But both of those are appropriate ways of representing your domain. So there you go. Now, this really confirms to us what we already knew. Because there aren't any wild transformations here, we know that we're going to have our standard asymptote for a log graph, which is going to be at x equals 0. So I'm going to come over here now, and I'm going to put in that asymptote. I come over here, and I'm going to write x equals 0. Now, I have to find my range as well, but we're just going to hold off for the time being because once I've actually drawn it, seeing my range is going to be a lot easier. All right, the next thing I could do is I could actually give this a general sketch because I know generally what it's going to look like. But before we do that, let me find what my x-intercept is going to be. So I'm going to say, to find my x-int, we're going to let y equal 0. So you should be very comfortable with doing that. We do that so many times in methods that it should be just second nature. So that means I'm going to let my y equal 0 and then just write it out like this. And then I'm going to have my 2x here. I'm now going to write it in index form because that's just easier for me to figure out what my answer is going to be. 10 is going to be my base, 0 is going to be my power, and my answer is going to be 2x. Then I know that 10 raised to the 0 is going to be 1, then it's going to be 2x. And therefore, remember, I'm trying to solve for this x. So I'm, of course, now going to divide both sides by 2. So I'm going to get a half equals x. So therefore, my x-intercept is going to be 1 over 2, 0. I now am going to get my highlighter, and I'm going to highlight it. Perfect. So now that I know that, I can begin to sketch out what my graph is going to be. Again, I already know in my head what the general log graph looks like. So let's draw that in now. Oh, that's not too good. Let's try again. Oh, I can't do it. All right, that is horrible. Let me try one more time. All right, there we go. It is really hard to draw on these tablets. There we go. Okay, there we go. And we know that this right here is going to be 1 over 2, 0. Let's see if I can draw that a bit better. It's going to be 1 over 2, 0. Just like that. Now, we can also figure out what my range is going to be now. My range, just by looking at this and knowing what range is just all the possible y values that I can get. And obviously, it's just going to be all real numbers. So I'm just going to write it like that. All real numbers is going to be my range. Now, you might be thinking to yourself, are we finished? You know, we've found my domain, we've found the range, we've found the x-intercept. Perhaps I'm done. But in reality, you're not done. And the reason why you're not done is because what we've drawn here is too general. It isn't specific enough for this specific graph that we've been given. In fact, this could represent a whole host of different ones. And let me actually prove this to you. This being the first question, I just want to spend some time proving to you that this isn't enough. So if I come down here and open up Desmos, what I've drawn here is log base 10 of 2x. So that is what we're after in this question. So if we come over here and we look, that's what we're after, log base 10 of 2x. Now, what if my base was different? So now, as you can see down here, my argument is the same, 2x, but now I have a base of 2. What does this look like? I draw it, and as you can see, it shares the same x-intercept. So if you just drew this, what tells me that this is log base 10 and not log base 2? You know, I could change the base again. Look at this. This is log base 100, and yet again, it shares the same x-intercept. So obviously, what we've drawn here isn't enough. It would be true for too many different graphs. So how are we going to rectify this mistake? And the way we're going to do that is by putting in another point. So we're going to find another point. So I'm going to come here, and I'm going to come here. Let's choose the color, and we're going to find another point. Now, in your back of the book, the point that they choose is for when x equals 1. So personally, I wouldn't use that point, but let's do it anyway. So if we had to do it, we're going to sub in x equals 1, which means what we're going to end up with is y equals log of 10. I'm putting x equals 1 here, so it's just going to be 2 times 1 is 2, so it's just going to be a 2 here. Now, do you know off the top of your head what log base 10 of 2 is? Because I don't, and that's why I don't like using it, because now I wouldn't like to use x equals 1, because now I'm going to have to, so this is 1 right here, I'm going to have to use my CAS calculator to solve this. So where's my CAS? It's over here. I'm going to have to come here. I'm going to have to go control log base of 10 argument of 2, then remember control enter to make it an approximate, so it's going to be 0.301. so I come over here and let's say this is 301. So this point right here has been found, and this is how your back of the book does it, like that. But theirs is a lot nicer, a lot neater than that. And that's really all you'd have to do. So now you've got 2 points, and those 2 points tells you exactly what type of graph this is. So it's now specific for when you have a base of 10. Now, if you did not like using your CAS, as I don't like using it, what's a better way to do it? Well, you'd have to sub in a different export. So let's now sub in and see if you can see why I'm subbing this in. I'm going to sub in x equals 5. You might be asking to yourself, why 5? Well, let's sub it in and see what happens. We're going to have y equals log base 10. Now, 2 times 5 is 10. That's right. Now, 10 raised to what power is 10? It's going to be 1. So that means when x is 5, my output is going to be 1. Now, this is way out of whack. Okay, this is not in any way to scale, but hopefully you can see that. Actually, let me try again, because that's horrific. All right, let's put it up here, and let's put it there. Let's say this is 1. All right, excuse the horrible drawing here. But again, if there are no, in the test, if there's no scale or grid lines, it's actually easier. If there are grid lines, you might thinking that they're trying to help you, but in fact they're not. So you have to be more accurate when they're grid lines. If it's just kind of free graph like this, as long as you put the right points in, I have to give you the marks, because this right here shows me what that you know what you're doing. So this is going to be 5, 1. So as you can see, that's a lot easier than doing letting x equal 1, than having to use your CAS like a silly person. So let's we can come look at our Desmos again. So we'll finish the question. So if we just come look at our Desmos again, and if we put in x equals 5, you can see that this green one is 5, 1, 5, 1. And that's obviously not a point that these other ones share. So the other one that we had was x equals 1. And yet again, you can see that by giving another point, 0.301, it's showing us that I'm after this line, log base 10 2x, not the other one. So by giving 2 points, that's what it's doing. I can just imagine that I'm going to get a lot of questions that say, do I have to draw another point? And you do. The only time you don't have to draw another point is when your log graph has an x and y intercept, because you already have those 2 points. You always have to have 2 points. There's no way around it. So if you only have an x-intercept, then you're going to have to put in another point. So I know what you're talking about. All right. I've talked enough in this video. Hopefully this was helpful and you now have a good understanding of this one, and hopefully this puts you in good stead for the rest of the questions.